bushings. Also, we've come up with a brand new underground method for pad mount transformers. It's revolutionary. It's probably going to be a big difference for the industry. Time, money savings, outage reductions, transformer savings. It's just a win-win for everybody. There's a whole lot of different scenarios that it sets up for. Helps with wind farms. Having to have three-phase transformer feed in, feed outs that are expensive. It's a cheaper way to buy a cheaper transformer. Also buying a cheaper transformer for the single phase. And we're going to kind of give you a little demonstration, go through it. I encourage people to think about it. I've had electrical engineers look at it. They agree with a lot of the points, and we'll just kind of go through them, and you can take a look at them yourself and see what you think. All right, here we're demonstrating just a regular single phase pad mount transformer, feed in, feed out. What we're doing here is we're feeding through the adjustable junction, and it's an external feed. We're not going directly through the transformer. You'll feed in here, feed out here, and then pigtail over, and you only have to need to buy single bushing transformers with this device. Some of the things are proven, some of them are theory. Like I said, we encourage people to think about it and maybe do some testing with it and see what they find out. One of the things that we're believing that will work is that the power reduction, you won't have as much power lossage going through here in and out as you do going through your transformer. That's a possibility. Another absolute though is you keep your cables up higher, you keep them straighter, and that takes the stress out of the bends because the wires tend to, under high load, they'll burn through and then blow out. If you burn up an elbow and you burn up a junction, which these are your main two hot feeds, and that's where a lot of your amps are going through. At this point, if you burn this up, all you change out is an elbow and a junction. Some of the other points to this that are good is when you're running, to only have to buy a single bushing transformer is cheaper. Also, is another theory that we have and believe that it's not a problem with working with that. We can quit getting fused transformers, which is an added expense to our industry, which you're pulling your bayonet fuse in and out to isolate your secondary side of your transformer. Here you would just pull off a cable and de-energize your pot and be able to work and still leave your loop intact. If this transformer goes bad and you need to change it out, all you got to do is pull your pigtail bushing off, and then you can isolate everything, have your crew set up, ready to go. And I propose dropping the switches and then changing the transformer out, get the transformer put back in place, put this junction back on, cover it up with a blanket, and then energize it back, and then you can finish up your transformer. When we start doing a lot of switching and going to the pots before or the pots after, you can tend to destroy your elbows, destroy other transformers, which is added expense, added cost, and outage time also. And that can be a big savings. Another great feature to this that this will do is with the feed in, feed out, all your external loads coming through here. But internal, when you're feeding through the transformer under max load conditions, you're building up amperage, which is adding heat to the transformer, which can help make the transformer go out. It's the heat buildup that can make them explode. One thing we want to talk about on the pigtail that's feeding the transformer for the adjustable bushing is I'm thinking we can use a copper cable, a little bit more flexible, a little more durable, going straight to our transformer. It doesn't have to be that long, but that can give us a good conductor, and we don't have a lot of expense, and that's something easy we can do in the field. I want to talk about here, we've got a 4-way adjustable junction, and we've got 4 cables on it. In this scenario here, we're demonstrating if you need to cut into your underground loop. Right now we're having to splice in a switching cabinet and come in out of it with the transformer. That's an added piece of equipment in people's yards that they don't like, and complaints from your customers. With this, you can just come in with your single transformer, your standoff bracket here, still standoff bracket here. Nothing's changed there. Still have a single bushing transformer, but you can have a cable feed in, feed out, pigtail over, and then can go to your house or another transformer inside your loop without having to add another piece of equipment. Here's another saving you about want to show. Let's say you got your loop, your feed in, your feed out, and your pigtail over. You have a lot of lightning problems and stuff. Here you can add a lightning arrestor on here to your adjustable junction. Gives you extra protection on your loops. Can be a real big feature to help there. Because if we can keep outages on underground coming through, we're going to be big help. Also, another feature this will help is fault currents now go through our transformers, going back out to the main line, to ground. That's kind of put shock load onto the transformers. This will reduce the fault current that the transformer sees. It will see a little, but it will reduce it, and can be a big help to saving the transformer's life also. Okay, also here's a good way to show. You can have a fused elbow in a transformer. Fused elbows are hard to put in pots right now because the way they are and they bow over, not a lot of room to work with. This gives you, picks your cables up higher, gives you more room off the ground, so you can have a little more room to work with your fused elbow, which gives more protection to your system and reduces outages. Another part to this, and this is for a 3-phase transformer, and I apologize I don't have a good setup scenario, but I can tell you how it's going to work. Right now, if you've got a 3-phase pot, you've got 3 bushings in there, and you got to extend you want to add another transformers. These are for industry customers with primary metering. If you're going to tie in all that, you've got to change the transformer out, and that's about $28,000 to $30,000 for a new transformer to change out. This way you can make your old transformer work. Also, with that 4-way the same way, give you lightning arrestor protection too on your transformer systems. But here you could just buy a 3-bushing 3-phase pad mount transformer using the adjustable junction, just adding 3 extra standoffs in it, and you'd feed in through the junction, feed out through the junction, and pigtail over to your transformer, the same method. This will also, if you burn up the elbow again and you burn up the junction, all you do is change out the junction and the elbow. You don't damage your transformer this way. And like I said, adding the lightning arrestor protection is a good thing also. If this transformer goes out with this method, locks out, burns up, and you're feeding in and feeding out to one more transformer at your business, at that point you're going to lose that other transformer. With this method, you just isolate your old transformer that's bad, and you still can run off your other transformer. Okay, here we're demonstrating what an extendable bracket can do. Spreads out your cables. I'm trying to get a manufacturer to build this now. It's not in production yet. I'm hopeful that we can get that done. But as you can see, you can spread your cables out, gives you a lot more sticks to get in there. Fused elbows gives you a lot more room to work, which they're kind of tight and cluttered with using on your regular cables. I think this can be a great help to us in the industry too. And if anybody would like to contact me to see how we might get this going, just shoot me an email. One other scenario with this that works real well is the wind farms. You're having to buy a lot of feed in, feed out transformers there, which is about an extra $6,000 to $7,000 that you can save in savings. Plus, the way as far as my research that I've been doing some studying on, is if you lose that first transformer off your loop, coming back when you're back feeding out to the main line, then your wind farms are down. This way, if you had a fused elbow here on your 3-phase pad mount and you lost this transformer because the wind coming up and down and throwing your transformers off, it would isolate this transformer and still keeping your other transformers and wind turbines working and producing. I'm talking to a manufacturer about building these parts. I don't have anything yet, but we're working on it. There's an attachment onto these junctions with this new underground system, and it'll be sitting here. It's already going to be high anyway. You just take your blanket, flip right over your brackets, and it covers your cables. Gives you a lot of cover for working on your secondary side of your transformer if you need to with this also.